going on, guys? Johnny Bannon here with Trepa Technologies. In today's video, we're going to go over our DHCP snooping lab. So in this lab, we're going to do a couple Wireshark captures. We're going to enable DHCP snooping and see how everything works. Just kind of get a good understanding of the DHCP snooping technology. And if you like these videos, make sure you like, subscribe, and share with people that love talking about networking and need to get CCNA certified. So with that being said, let's go ahead and get started. I'm going to minimize my face. Actually, I'm just going to get rid of it. And then let's go ahead and get started on our lab. So as you can see here, we're on EVE-NG. We have our network diagram here. Let's just quickly go through this and see what we got cooking. So as you can see, we have 3 switches. We got switch 1 here, 2, and 3. We have our DHCP server, which is just a Cisco iOS device acting as a DHCP server. It's a router. And we have 2 VLANs. So we have 2 DHCP pools here configured. We got sub interfaces, and then we have trunks all along here. And then we have our computers. So as you can see, we're not going to go over the trunk, the VLAN, the sub interface configuration, and the DHCP pool configuration. If you want to learn how to do that, we have videos in our previous lessons. What we're going to check though here is that DHCP is already working. So now we need to configure DHCP snooping. So the first thing we're going to do before we configure DHCP snooping is we're going to minimize this. So we're going to go over which ports are going to be trusted and which ones are going to be untrusted. So before we do that, we have to go through kind of the flow of how a DHCP quest would happen. So let's say we're computer 8 here in VLAN 20. When we want to get an IP address via DHCP, we again do of course we do our door process. So we're going to send a discover out here. Now remember, untrusted ports can only receive client messages. So this is going to be untrusted. And then if we have everything working correctly, like this is our root switch, which we have to make sure of, if we're going this way, then this uplink is going to be trusted, because once we go to our DHCP server and that DHCP server gets our discover message, it's going to send an offer back. And remember, trusted ports only accept DHCP server messages, which would be that offer. So back down, the offer request would come in here. So it would be received on gig 00. And then again, if our traffic is working like it should, with this being the root switch, it should just send traffic down here. And then gig 02 would be our trusted port. Now again, with this kind of network diagram, what do we have to be aware of? Well, let's say for some reason that when our computer here sends that broadcast, we go this way to the root switch. So now this gig 0 would have to be trusted, and this would be untrusted here. But then we have to think about this computer here. What if this computer went this way and back up? Well, that wouldn't work, because this would be trusted here. And remember, trusted can only accept server messages. So the point of this being is that in this network diagram, we have to ensure that we have our spanning tree configured how we want. So essentially, one of these two should be discarding, and we shouldn't have to worry about this trunk here being trusted or untrusted. Unless, of course, something happens and this goes down, then we'd have to go back in and architecture it out to make sure that we have these as the correct trusted and untrusted ports, okay? But for now, we shouldn't have to worry about this link. And we're going to verify that. We're going to make sure that for VLAN 10 and VLAN 20, that switch 3 is sending traffic straight to switch 1 here. And then switch 1 is sending it straight there, okay? So that's part 1. Define our trusted and untrusted. Then once we do that, we're going to enable DHCP snooping on switch 3 and switch 1 here. Because just for testing purposes, we're just going to do this VLAN 10, okay? And then once we do that, we're going to have VLAN 10 actually do the door process. And when we do that, we're going to do a Wireshark capture on this interface here and this interface here. So we're going to look at that packet capture. And what we're going to run into, I suspect, is that option 82 is going to be an issue. Because essentially what's going to happen is when that option 82 gets sent out this trusted port, it's going to drop it. Because it's going to think that it just drops it. That's part of the DHCP snooping operation if it has an option 82 attached to it. So we may have to put the no IP DHCP information option globally on switch 3 and over here on switch 1, okay? So with that being said, let's go ahead and get started. So again, the first thing we're going to do here is make sure that we're optimizing our traffic flow, making sure it's going like this and not like this, okay? Because once that we know the traffic flow is like this, we can architecture out our trusted and untrusted ports. So let's go ahead and bring Secure CRT back into view, and we're going to start on switch 3, and we're going to check. So we're going to do show spanning tree VLAN 10. And we're going to see that the root port is gig 02. So that is exactly where we want to go. Gig 02 should be sending towards the root bridge switch 1. And one thing we can do here just to make sure is on switch 1, let's just go ahead and do spanning tree. Let me bring this into center. We can just type in spanning tree VLAN 10 root primary, just to double make sure that it's going to be the root switch, okay? And now that we know traffic flow is optimized here, let's go ahead and go to PC7, because that's going to be our VLAN 10 PC, and let's just test DHCP. We're going to type in IP DHCP, and look at that, we're good to go. So we know DHCP is working. Now what we're going to do is we're going to go into switch 3 here. We're going to go into interface gig, connected that 1.1, and we're going to shut that down. And then we're going to just restart this computer here. So we're going to stop it. Hopefully stop it. Okay, there we go. And then start it again. My EVNG instance is on the Google Cloud platform, so sometimes you just get this little lag with actually sending like clicks from the mouse all the way to the Google Cloud. And then we're going to no shut this. And now before we send another door request, we're going to start packet captures on gig 02 here. So we're going to right click, capture on gig 02. And then we're also going to do a packet capture on switch 1 here on gig 00 towards our DHCP server. And those packet captures are going to run in the background. Let me just input my root key real quick so we can do this Wireshark capture. Okay. Sometimes, again, you have to do this with Wireshark. You have to actually SSH to it. And then we have to restart those packet captures. So let's go ahead and right-click that again. Gig 02. And now that should just launch Wireshark right away for us. And let's capture gig 00. Awesome. And then, of course, we have our packet captures over here. So this is the packet capture from gig 02 on switch 3. And then this is the packet capture from gig 00 on switch 1. I'm going to make sure I don't get those disorganized. Okay. Awesome. So we have our packet captures there. Now let's go ahead and actually configure DHCP snooping. So we're going to again go back into Secure CRT, bring that up to the middle. And the first command we do is type in IP DHCP snooping. We're going to enable it globally. And then we're going to do IP DHCP snooping VLAN 10, and we'll do VLAN 20. And then we have to define our trusted port, which is going to be gig 02. So we're going to go interface gig 02. We're going to type in IP DHCP snooping trust, and that's going to be our trusted port. And now we're going to go back into switch 1 and do the exact same thing. So we're going to do interface, or actually, excuse me, IP DHCP snooping, enable it globally, then type in IP DHCP snooping VLAN 10 and 20, and then we're going to go into interface gig 00, and that's going to be the one that's receiving the DHCP server messages, and we're going to type in IP DHCP snooping trusted. Sweet. And now back on PC7, we might have to just remote back into it. Or actually, let's just go ahead and make sure that it starts. All right, there we go. Back into PC7. We're going to do, let's see, show IP. So we have nothing. So we're going to do IP DHCP. And let's see if that door request makes it. So just because I've worked in EVE-NG a lot, this DHCP request is not working. So let's go see why. So we have our packet captures up here. So I have this packet capture, and this is the one going from switch 3 gig 02 up. So let's look at that packet as it exited gig 02. And what we're going to look at here is just filter it by DHCP. Okay, so we have this discover message sent 3 times. So let me just expand this Wireshark capture, zoom in just a little bit. So if we look up here, we actually want to look at the DHCP header packet. We can see this option 82 here. Okay, now this is the reason why. Because when it gets sent out a trusted port, it's going to say you can't exit. We're going to block that message. So if we come back to secure CRT on switch 3, let's actually do some debugs here. Let's do debug IP DHCP snooping. And let's do event. We'll do packet as well. Okay, now let's resend that DHCP message and let's see if we get anything back on switch 3. Okay, now we're going to hit you all, and this will stop it. There we go. Okay, so as we can see at the very top here of our debug message, we can see process new DHCP packet type, discover input. Okay, add relay information. So it added relay information and added that option 82 to the DHCP packet. Okay, somewhere in here it should say that it was dropped. And this may be done on actually on switch 1. Yes, excuse me. So when it comes in on the untrusted port, it's going to deny that. Not when it goes outbound. When it comes inbound on that untrusted port, that option 82, it's going to block that message. So you see here, message drop 82 value on untrusted port. So untrusted ports are the ones that will not allow that option 82 inbound, okay? So we can actually come here and see for this Wireshark capture, this is going to be from switch 1 to the router. It never even made it, okay? Now let me just make sure that we have this other packet capture still going on. Okay, we're going to leave that capture on. And on switch 3 and switch 1, what we're going to do is we're going to type in IP DHCP information or snooping information option, and then that's it. Okay, so we're going to do that, and then on switch 1 we're going to do the same thing. We're going to type in, because essentially what's going to happen here is probably the same issue. We're going to type in IP no DHCP snooping information option. And now back on PC7, let's see what happens. So now the door process goes through. And if we look at this switch 1 here, we don't get that syslog message telling us that. And then we turn off our debugging. I should have kept it on so we could see that it didn't add it this time. And if we go to our Wireshark capture, now look at this. We don't have the option 82 anymore where we did it previously. So now our DHCP snooping is working. So pretty cool. So you may be wondering, why does it do this if it knows networks are going to look like this? Well, because untrusted ports, remember, only allow client messages, and it believes that that relay information is going to be a server message. So it's going to drop it. Now, when they did DHCP snooping, I'm going to assume that they had it for a network like this, where there's the DHCP server connected right there. So you wouldn't have that issue because this wouldn't be an untrusted port. So you wouldn't have to worry about that 82 information coming in on the untrusted port and then getting dropped, okay? Now, we know DHCP is working now, so let's go ahead and check the snooping table. Let's go ahead and look at our DHCP snooping binding table. So we can type in show IP, DHCP snooping, and then let's look at we can just hit enter here. And this is going to be a kind of more information than what we want. What we want to look at is the actual table here. So we're going to look at bindings, okay? And then we can specify it further for which VLAN, which actual MAC address, but we don't have nothing on this switch but one computer. So as you can see here, we can see this source MAC address here is tied to this IP address. And this is going to be useful during the starvation or DHCP poisoning attacks, referencing this binding table. All right, awesome. So that is going to cover it for this lab. I want to thank everyone for viewing. And stay tuned for our next lesson where we're going to go over dynamic ARP inspection, which actually gets built off the DHCP binding table. If you have any more questions on this, please feel free to reach out to my team description below. And if you're an active duty, Reserve or National Guard U.S. Army soldier, you get free training with us. If you want to attend our live virtual training boot camps or enroll in our self-paced training, it's completely free to you. Check out that link in the description below to see how you can apply for Army Cool and get $4,000 in assistance for certification training. Thank you for viewing.